Have you ever stopped to think about how a secret message actually gets from one person to another completely safe from prying eyes? I mean, in our world today, we're sending secrets all the time, every single day, without even thinking about it. But the story of how we keep our digital lives private, it's a really fascinating one, and it's built on ideas that are thousands of years old. So, how does it all work?
That's the core question, isn't it? How do you create a totally private channel in what's essentially a completely public space, like the internet? Well, the solution is this really clever mix of old-school ideas and brand-new technology. Let's break it down.
So to really get this, we need to meet the classic characters in the story of cryptography. First up, we have Alice. She's the one who needs to send a secret. Then there's Bob, her trusted friend who's supposed to get it. And finally, you've got Eve, who, as her name suggests, is an eavesdropper.
And right there, that's our whole dilemma. Alice and Bob have to communicate something important, but they know that Eve can listen in and grab any message they send. So the big problem is, how can Alice get her secret to Bob without Eve figuring out what it says?
Okay, before we dive into all the digital stuff, let's use a super simple physical analogy that makes this entire concept just click. It's all about a lockbox. Seriously, if you get this, you'll understand the foundation of all modern cybersecurity.
The plan is pretty straightforward, just 4 steps. First, Alice writes down her secret message. Second, she puts that message in a sturdy box and locks it with a combination that only she and Bob know. Third, that locked box gets sent out. And finally, Bob gets the box and uses that same secret combination to open it up. Now, Eve might be able to grab the box while it's on its way, but without the code, the secret inside is totally safe.
Now, this act of locking the secret away has a special name. It's called encryption. In the digital world, instead of a physical combination, what we use is a secret key to basically scramble the message, turning it into a secure, completely unreadable format.
And on the flip side, when Bob uses that exact same secret key to unlock the message, well, that's called decryption. It's just the process of unscrambling all that data back into its original readable form. It's that simple. You lock and unlock, you encrypt, and you decrypt. That's the fundamental cycle of all secure communication.
Okay, so here's the million-dollar question, right? It's easy to picture a physical box with a lock, but our secrets, our emails, our texts, they travel through wires and airwaves. How in the world do you put a digital message inside a virtual lockbox?
This is where things get really cool. This is where cryptography truly begins. We have to completely let go of the idea of physical locks and make the leap to something else, something called a cipher. This is how we build those virtual locks.
So, what is a cipher exactly? You can just think of it as the digital version of our lockbox. It's not a physical thing, of course, but a set of rules, an algorithm that tells you precisely how to scramble a message to make it unreadable, and then, just as important, how to unscramble it back to its original form.
And when you look at it this way, you can see just how perfectly that physical analogy maps to our digital reality. The lockbox is the cipher. The combination is the secret code or key. The act of locking the box, that's encryption. And unlocking it, that's decryption. The principles are exactly the same. They're just translated into the language of software and data.
So here's the absolute key takeaway. When Alice uses a cipher to encrypt her message, it gets scrambled into what looks like complete and utter gibberish. This means if Eve intercepts it, all she sees is random, meaningless data. She has the message, sure, but she can't understand it without the secret code to decrypt it.
So, how do we create a cipher that's so strong that someone like Eve can't possibly break it? This is where it gets really amazing. Because it's not magic, it's math. The incredible strength of modern cryptography comes from some very old and very powerful mathematical ideas.
You know, modern cryptography is really built on 2 super powerful fields of math, number theory and probability theory. Number theory gives us problems that are actually pretty easy to do one way, but incredibly, unbelievably hard to reverse. Think about multiplying 2 huge prime numbers together. It's easy to do, but trying to figure out the original primes from the result is almost impossible. And probability theory helps us make sure that scrambled message is truly random, leaving no clues or patterns for Eve to find. You put those 2 together, and you can create digital locks that are, for all practical purposes, unbreakable.
Now, all this might sound like a fun theoretical puzzle with Alice and Bob, but the truth is these principles are working silently in the background of your life every single day. So why does all this matter so much? Well, let's take a look at where these digital secrets are being protected right now.
And look, that quote is no exaggeration. This isn't just some dramatic statement.
Cryptography has literally shaped history. It has been the deciding factor in actual wars, and today, it is the invisible engine that powers our entire global communication network. Every single secure thing you do online depends on it. Just think about it for a second. Your private data stored on your phone or computer, the security of your online banking, the privacy of the messages you send to your friends and family, all of it is protected by the exact same principles of encryption and decryption we just walked through. It is the guardian of our digital lives.
And that brings us to a final and really crucial question. You see, the technology of secrets is a constant race between the code makers and the code breakers. As our world gets more and more connected and new threats like quantum computing start to appear on the horizon, the challenge of keeping our information private is only going to get bigger. The question isn't just how we protect our secrets today, but how we'll adapt these ancient mathematical ideas to guard the secrets of tomorrow.